so here's the next question for the Leetcode, that is closest prime numbers in range. Okay, so in this we have given two numbers, that is left and right, and we have to basically simply find the two prime numbers between them whose are the basically smallest difference, whose have the smallest difference between them, okay, or gap. Okay, so let's just take two example and you will understand better. I have taken this left and right, that is 10 and 19. I have calculated all the prime numbers between them, that is 11, 13, 17, 19. Or so 19 and 10, these are left and right values are also included. Okay, so 10 was not a prime number, so I have not written it. Okay, so if you see, the smallest difference between them are 2, that is 11 and 13 and 17 and 19 pair. Okay, but we have to return these smallest numbers. Okay, 11 and 13, not 17 and 19. Okay, so that's the basically question. We have to always return the smallest pairs. Okay, so how can we basically do it? So first basically approach is that we from 1 to right, basically in the right number. Okay, we can simply find all the prime numbers. Okay, but for finding prime numbers, what are prime numbers? A number that is only divisible by 1. Okay, not any number between 1 to n. Okay, that is divisible by only 1. So for this basically we have to for every number we have to check is it divisible till basically is it not divisible by anyone. Okay, so for this basically for we can also optimize this by only checking till square root of n. Okay, so to do this it will simply give TLE, because right is here, if you see constraint, that is 10 to the power 6. Okay, 10 to the power 6 number can basically right could be there till 10 to the power 6, so it is so long basically. So for checking till this for every number and then simply taking it, so it will simply give lots of time. Okay, and it will simply give TLE. Okay, so to do this in better approach, we are going to use this Sieve of Eratosthenes. Okay, so what this method is, this is the best method to find all the basically prime numbers between a range. Okay, or you can say from start to the limit. Okay, so I have taken the only 25 numbers to how basically this Sieve of Eratosthenes works. Okay, we will see. I have taken these 25 numbers and we will find all the possible prime numbers using this in this method. Okay, so one is not a prime number, not a composite number, so I have crossed it. Okay, so simply we will start from 2 to 25. Okay, so simply what this approach is like, it start from first. Okay, it will take 2 as a prime number and it will simply cross all the multiple of 2, that is it will simply take 2 as a prime number. Okay, and simply it will cross all the basically multiple of 2, that is 4. Okay, if I cross it, then it will simply be like this, it will simply cross 4, and so I have crossed out all the multiple of 2. So after this what happens is that it moves to the next number that is not crossed. Okay, that is 3. 3 is also a prime number, so it will mark as 3 as a prime number, and it will simply cross then again all the multiple of 3. So 3, and then it will cross this 9. Okay, and then 12 is crossed, 15 is not crossed, so it will simply cross 15, and 18 is crossed, then 21 is not crossed, so simply it will cross 21, and 24 is also, so all the multiple of 3 is also crossed. Okay, so it will simply then move to the next not crossed element, that is 5. Okay, so simply it will cross all the multiple of 5. Okay, so simply 5 has all the element, that is here 25 is not only crossed. Okay, it will simply cross 25 also. Okay, so then it will move to the next element that is not crossed, that is 7. Okay, so 7 has all the multiples crossed. Okay, then it will move to 11, that is the next element that is not crossed, so it has also, so all the numbers are crossed, then 13, then 17, then 19, then 23. So you will see that all the elements remaining here are prime numbers. Okay, so this is the method that we are going to use to form a prime numbers array. Okay, so this will simply form in much less time. Okay, so you got the thing how this approach will work, Sieve of Eratosthenes. Okay, by this let's just take the example, and I will just tell you how we are going to do. Okay, So let's just take it. Okay, and what we are going to do is we will just form all the prime numbers till 1 to 0 to 19. Okay, so what we'll do, we will simply let's just form a table. Okay, this. Okay, I have formed all the basically indexes that is 0 to 19. Okay, so what we'll do, we will simply put 0 if it is a not prime number, and if we will put 1 if it is a prime number. So whatever, first 0 and 1 both are not prime number, so simply we will put 0 and 1 here, and at 0 it is simply 0, and 1 also it is 0. Then for 2 it will simply put first 2. It will simply, what it will do, it will simply put all the basically first it will put all the numbers at 1. Okay, and then it will check 0. Okay, so let's just put all the numbers as first. I have put all the numbers at 1 and first two number at 0 because it would be simply not prime number. Okay, so for first it will simply check if the number is 1. Okay, for the basically number is 1, it will simply check all, it will simply make all the multiple of that 0. So simply it will make this it is 4 as 0. Okay, let's just make 4 as 0, and then I have make all the multiple of 2 as 0. Okay, then it will simply move to next element that has value 1, that is 3. Okay, it will simply move to 1, and it will simply make all the basically multiple of 3 as 0. So here you can see 9 is not 0, then it will simply make 0, and 12 is 0, 15 is not 0, then it will simply make 0, and 18 is also 0. So then it will simply make 5. It will move on next one element, that is 5. So it will simply make all the elements of 5 at 0, so simply they are 0. Then it will simply move on 7, that is here, so it is 1. Okay, it is 1. Okay, so simply it will make all the element as 0 of the 7, so it will 14 is 0. Okay, then it will simply move on 11, so it will simply 11 has no multiple, then it will simply here it will be 1. Then it will simply on 13 and 17, and it will simply at last will come on last. Okay, then what we'll do, we will simply put all the numbers that have basically listed as 1, we will simply put in a prime numbers array, that is simply have the prime numbers. Okay, it will simply put all the numbers that is 2, that is 3, that is 5, that is basically 7, and that is 11, it's simple 13, and that is 17 and 19. Okay, so it will simply form an array with all the numbers that was prime number. Okay, then at last what we'll do, simply we will iterate through this array. Okay, and we will simply find the minimum difference between two. Okay, simply we will iterate through this array till last, and we will simply find the two numbers that will simply give minimum difference between them. Okay, so first two numbers, that is 11 and 13, will simply give. Okay, and we will simply return this. Okay, so one thing basically I have not done, this prime number array would be formed from left to right. Okay, so if I write here, then it will simply get these number. Okay, we will not from 0 to basically. Okay, so simply it will give only 4 numbers, and we will simply get minimum difference between them. Okay, iterate through. Okay, we will iterate through, and we will get minimum difference between them. So this is the approach what we are going to do. So you got that. Okay, we will just see in Leetcode also. Okay, so how we are going to do. Okay, so that was the code. Okay, so here's the code for the this closest prime numbers in range. Okay, I have written in Leetcode. So what we are going to do, let's just make first understand the main function. Okay, this vector int sieve array. Okay, we will simply we have make a sieve function that will simply make a sieve array, that is 0 and 1 off. Okay, you have seen that. Okay, first we will simply put those from left to right prime numbers from that matlab sieve array. Okay, all the prime numbers from left to right, and then simply we will check if the size is smaller than 2, we have to return -1. Okay, we will simply calculate the minimum difference, that is we will take minimum difference equal to int max, and we will take a pair array. Okay, that has the size 2 and first we will initialize with -1, then simply we will iterate through. If the difference with this prime number I and prime number I -1 is less than minimum difference, we will simply store the pair 0 and pair 1 at this. Okay, we will simply return pair. So let's just take how the sieve array is formed. So we have just taken this right till right, we will form this sieve array right plus 1, okay, one extra size, and we will first initialize it. Then first two element, that is 0 and 1, we will simply put 0 at the first two index. Okay, then we simply start from 2 till right. Okay, and then simply we will, if the value is equals to 1, then we will simply multiple of, we will check for every multiple. Okay, and then we will put 0 at the index. Okay, we will simply return at last C. Okay, so that's the basically code for this. I will provide you the code in GitHub also, and you can simply run it or submit it. So yeah, I have submitted, so it's accepted, and you can see also time complexity of this, that is square root of n. Okay, so and here's space complexity is big of n. Okay, so that's the code.